Guys, in this video, I am explaining how you solve a matrix system of equation with MATLAB. Okay, now first thing, when you try to solve a system of equation like this, you can see we have three equations and three unknowns. We need to convert this problem into matrix problem. The matrix form of this system of equation is this second one. You can see when you're multiplying, so what you do is first row multiplied by this column, so then you get this answer. So if you look at the first row, 1x 2y plus 3z, that is equal to 12. So that is our equation 1. If you look at second row, 3x plus 4y plus 5z, that is equal to 60. That is our second equation. If you look at third row, that is 4x plus 7y plus 2z, that is equal to 60. Now you can see this matrix and also system of equation, they are same. Now we will see how you can solve this system of equation with MATLAB. I will do this calculation in a new script file. I will now name it as a system of equation. Now, first thing, we need to create matrix to represent this system of equation. My matrix A that represent 1, 2, 3. That is first row. Second row, 3, 4, 5. Then my third row, 4, 7, 2. Okay. Then my matrix B, that is the output answers. So they are 12, 60, and 64. We have a few different ways of doing this. So first I will explain like how we solve this with the inverse matrix. So here, to obtain inverse of a matrix, we have command inv. So then if you look at the helps, you can see it generate matrix inverse. Now let's say my first set of solution, that is equal inv inverse A multiplied by B. I will execute this one and we'll see the answer. See, so now these are my answers. So if you go back to the problem that we had, and this is our problem, right? Now, so this is in form of like in this form A x that is equal B. Now I can write, so we have left hand division or inv A. This is what I did. Okay, so then if I go back to my working, okay, in this way I can obtain the solution. Method 1. Now my method 2. I can directly use this command. So look at this line solve. So you can see this one help us to get the to solve the set of linear equation. Now, so first my coefficient matrix A, second my output matrix. When I enter it like this, if I run this one, see, I can see the same set of answers. Now, third method, let's say my set of solution matrix. So that is, I can use the just power to calculate this one. So now it's B. If I execute this one, you can see my S3 also same. And if you look at the workspace, all these three metrics are same. So they have similar set of numbers. Now, next one. So we can solve this by using row echelon form. I can to get, let's say like just merge matrix A and matrix B like this. Now if you execute this one, you will see it will generate like matrix like this. All what we did is we put this output matrix along with the coefficient matrix. So then we take simplify it to row echelon form. So for that we use so you can just help RREF. Okay, reduce to row echelon form. So when you want to reduce this matrix into row echelon form, you can use this function. So now feed RREF. So then you feed your matrix C. So then we'll see what it produces. See? So now this last column represent the solution of this matrix. For now, I will put semicolon. Now, what is the method to get this last column? So you can take S4 is equal. So if we need all rows, so because of that we put colon, comma, n. To say like last column, you can put n. So if you execute this one, you can see you are getting same matrix. Now next thing, like when we have all this method and when we calculate the solution, we need to check that how much it is accurate. For that purpose, we can use metric norm. So let's say I want to check the accuracy of this S4. So then I can write. So it is kind of like magnitude of the matrix. This norm represent a magnitude. So now we want to get the magnitude of like S4 minus, so the solution A left divide B. Now we'll execute this one and we'll see what is the magnitude of this one. Okay, it's a very small number. That means, so this is the different solution and the solution S4 and this matrix. So you can see this difference is very less mean. So this S4 matrix that is very accurate. So this norm gives kind of like indication about this matrix magnitude. This magnitude of this matrix should be minimum. So then we call it is more close to the actual answers. Okay, thank you very much for watching.